Welcome back, everyone. I want to thank Ashlyn and Morgan, as well as the ET staff, for leading that breakout session. I've heard amazing things that you guys were hard at work, and we can't wait to see. I hope we have lots of schools ready to share. First, I'm going to hand it back to Joanna so she can kick off this Q&A wrap-up session.
Thank you, Jillian. I too am really excited to hear about your discoveries and what you learned as part of this lab. I have so many takeaways when I did it, and I can't wait to hear what you found interesting and what worked for you. But before we get into that, I'm so lucky to be joined by two of our college mentors, Romina Kumrani and Morgan Douglas. And I'm going to let them introduce themselves to you, and then we're hopefully going to hear from you and some of your discoveries. So, Romina, why don't you take it away?
Hi guys, my name is Romina and I'm currently a senior at Virginia Tech. I'm double majoring in Spanish and civil engineering, and within civil engineering, my focus is in structures. I've actually been part of Steel Bridge with Morgan before, so her and I have had many classes together, and I'm so excited to be joining you guys today.
Thanks, Romina. And now let's hear from Morgan.
Hi everyone, my name is Morgan. I'm also a senior at Virginia Tech, but my main focus is sustainable land development. So that is the designing of neighborhoods, cities, different shopping centers, and making sure that they are sustainable so they can be used for years to come. I'm also pretty interested in stormwater management and water resources, so making sure all the water is clean. So pretty similar to the lab that you all did today and our clean water lab as well. But I've also been a part of American Society of Civil Engineers and Steel Bridge, similar to what Romina mentioned. But I'm really excited to see all your designs.
Well, Morgan, you have to tell everybody the big
Yeah.
exciting news.
So this past weekend, I had the unique opportunity to go out to West Virginia, and we competed as a team on steel bridge. So we design and fabricate our own steel bridge, and then we load it and we test it and we construct it. And we placed first in all categories. So we are going to nationals. So that is really exciting. We competed against schools from West Virginia and Virginia. So I'm really excited for nationals now.
That's wonderful. And I'm also reminded of collaboration there when you and all the different people that you worked with. And I think when we think about remediated sites, there are so many stakeholders in a cleanup process. And I wondered in some of your water resources classes, have you started to look at that, or have you already worked on case studies where you might be working in communities?
Yeah, in it's not a water resources class, but it is sustainable land development, that class. And one of my like adaptive reuse classes, we talk about how there are so many stakeholders, like whether you're just developing a new site or you are redeveloping an old contaminated site as well. So you kind of got to think about working with the government, working with the people living around the site currently, working with construction managers, if you are the civil engineer, working with the architects as well. Next semester, I'm actually taking a class called Collaborative Community Involvement. So that is really tied together with making sure all stakeholders have a voice, and also the community values are also kind of being taken into account.
So important. And I think it's going to be a theme that you're going to hear more of today, especially when our keynote speaker is talking with us, the importance of communication and those soft skills that a really, a talented engineer needs. Romina, I know in building a structure that the same is true. And I was wondering if you had any case studies that you wanted to mention before we hear from some of our students.
Yeah, I know I mentioned that my focus is in structures, but I've done internships in construction, and like the closest thing that would be related to today's like lab is kind of the water contamination that happens on site, especially like I think at one of the like affordable housing projects that I was on, from rain and everything. I think there was an issue with the pump, and so the water was contaminated. They were trying to pump it out, and so it was like a whole mess. And so they needed to like we needed to all figure it out, and like go on site. And so it it ends up involving a lot of people, a lot of time, just to try to figure out like a solution to those kind of things. But it goes back to show like how much collaboration goes into these kinds of like solutions. So yeah.
So important. And I also think empathy, like as engineers, we also really need to understand, look at a case from the viewpoint of our stakeholders and understand what the community needs too. So I can imagine being in a community where a housing project doesn't have adequate, has a problem with their drinking water supply or something. You can imagine that you need to feel for them and take action, and that also has to go into your design process. So speaking of that and kind of thinking about what this remediated site means to our student groups, I was wondering if anybody's starting to get ready to share. I know you've been busy at work. Is anybody ready to share their designs yet? I see Jerry.
Joanna, Jerry Dawes here. Whenever you're ready for us.
Okay, let's
I'm going to
spotlight,
stop sharing and we are ready.
spotlight Preston High School. There we go.
Good morning, everyone. Jerry Dawes here, staff engineer, engineering tomorrow, on location, Preston High School, Bronx, New York. We have 3 teams. Students have done very, very well with this lab, learning all about contamination and various remediation processes. So I'd like for team number 1 to come on up. Jade, Mariana, and Rita. Let's talk about your experience.
Good morning, ladies.
Hi, good morning.
Good morning.
Hi.
All right, go ahead and talk about your experience with this particular lab.
So when we first, my first thought was to make a boom. So we made a small one, and when we poured the oil actually stayed in the middle of the boom. So what we did was we took the pipette and we started scooping up all the oil, and this is like pretty much how much oil and like all the dye we got.
Yeah, like she mentioned, we first used the boom and it kept the oil pretty contaminated, but then we used the pipette and it kind of like made the oil disperse more. The dye was already it was just like everywhere. So after that, I think we used soap.
Yeah.
So we used soap, and it made like it dispersed the oil within the water mixture, but I think it made it harder to pick up the oil like from like certain areas because now it's just all over the tray.
Yeah, and I had that all of a sudden the as soon as I put a drop of Dawn dish soap in, the oil droplets they got smaller. It looked like they started to break it apart, and you could imagine that in an ecosystem, maybe that would help break down the oil faster and not have it sort of be so detrimental to the shoreline and things like that if it happened.
Yes, we also used the yeast packet, but I think that the proportions were off. So if we would have used more yeast, we could have generated more carbon, right?
Yeah.
But it wasn't enough, so we didn't really have a lot of anything going on with that.
And that takes time. So you might still be surprised. It can take an hour or so. So, well, wonderful. I'm sorry, that the
Excuse
third
me,
member of the team want to say something.
Yeah, Joanna, we do have one team that actually tried the yeast. This is the bioremediation process, and we actually have some gases building up. So we want to demonstrate that to you. So I'm going to have team number 2 come on up.
Thank
Ready?
you,
And
team
Irene.
1. Team 1 did a great job. Thank you.
Yes, thank you,
Round of
team
applause
Thank you
for
guys
team
for
number 1. That's
sharing.
Jade, Mariana, and Rita.
Yay.
Thank you.
Hi, team 2.
Okay. All right. So this is team number 2, Areti and Irene.
Hi.
So yeah, we initially started by adding dish soap to the oil, although like in hindsight, it probably would have been easier without the dish soap because combining dish soap and then a removal technique, since the particles become smaller, it's a little difficult. But after that, we used a skimmer and then dredged up the oil. Um, I would say that that worked pretty well. We ended up with this, and the balloon kind of inflated a little bit after we added the yeast.
Yeah, so there's some gases being released and we can see it in the balloon right here.
Yeah, and I think if you leave that on there for an hour, you might find that you get actually quite a big balloon. So wonderful.
Yeah.
Great. All right. So a round of
Can I
applause
just-
for
can I just
Areti and Irene.
Oh, okay.
Oh, you have a
Jerry,
question for
yeah,
you have a
question.
question for them, Joanna?
I was just going to ask a follow-up question. Like when you did your lab, did you imagine a place where this was occurring? Did you think about sort of your where is this oil spill happening for you?
I did actually. I used to live on this island in Greece, Lesbos.
Whoa.
There's this Bay of Yera, which there was actually an oil spill there a few years ago, and that's where I imagined it being. It opens into the Aegean Sea.
Wow.
Oh, what a unique example. And what a, I can only imagine all the villages around there being potentially impacted and so many, a highly populated area being impacted by the oil in the water. And the beaches, the beautiful beaches of Greece that would be terrible.
Yeah, especially because a lot of locals fish and from that bay and eat the fish.
Yeah, yeah. Oh, what a unique and amazing example. Thank you so much, Team Two.
Thank
Yeah.
you.
Thanks for
Team, so
sharing.
that was a round of applause for team 2. That was Areti and Irene. And our final team from Preston High School this morning will be Madison and Rachel. Come on up.
Come on up. And Morgan, Romina, and Joanna, I love that she said in hindsight, because that's what it's about, right? Learning from
That's
it.
right. Learning from the example.
All right, so here's Madison and Rachel. Joanna, take it away with questions.
Hey,
For our experiment, I feel like we definitely faced lots of struggles, and I feel like it shined light a lot on like the reality of pollution, and I feel like it spread like really fast. So I think like it can like it's like a really good example to like show the effect that it has on the environment, and I feel like it also like helps to shed light on like the fact that like it's not an easy process at all, and like it's a tough job for lots of environmental engineers, and I feel like it was nice to be able to like get a glimpse of that.
oh, I'm getting goosebumps,
Me too.
Rachel. Thank you so much for your testimony there because I found the same thing. Oil is really, really a hard thing to remove from the environment. And I want to turn it over to Morgan and Romina as well with their questions because I know they've particularly Morgan has had to think a little bit about this in her water resources work that she's done.
Yeah, well, I was just gonna ask what kind of remediation and what kind of method do you use? So I was wondering if you use like a boom or did you try the absorbent methods?
We used a boom, but then we also tried some absorbent methods. And like I feel like the dish soap, it definitely did make it harder, like Aditi said, because like it like all of the things got like a lot smaller. So it was like harder to collect. But I feel like the boom and like the absorption, like I feel like it's a pretty popular process. And I feel like the difficulty of that, it definitely showed like how intense this is.
Definitely, because you got to think about how small scale your current one is, and if this were to happen in a sea, in like a gulf in an ocean, just think about how much money would go into trying to fix all of this pollution as well. Romina, do you have any questions for them?
Yeah, mine is more of a commentary. I liked that I'm seeing like between all of them that they're like noticing all those like environmental impacts and how like it would impact the wildlife as well as like the locals, which is very important. But I know everyone's been mentioning that it's very difficult, it's time consuming, and it is true, but at the same time, it's very rewarding that we have people that are able to do these kind of things and use their like engineering skills to be able to find a solution to help with the oil spills. So maybe in the future, you guys can be, those engineers that help out with that. So good job, guys. Very exciting.
I think you're right. I think you're right, Romina.
Yeah,
Do you have
wonderful
any?
job. Rita and Rachel, did I have that right? Rita and Rachel?
Madison and Rachel.
Madison and
Madison and
Rachel,
Rachel.
sorry, Madison and Rachel. Well, wonderful, wonderful job. And
Yeah,
and
great
I
work.
want to add, I really liked Romina and Morgan's comments. I think environmental engineers, mechanical engineers, civil engineers, all the disciplines, you can work on such a wide variety of projects, and environmental cleanup being one of them. And a company like my former company, Bechtel, works on a whole variety of projects and takes on some of the most challenging projects around. And so if that's of interest to you, using your knowledge for good, there are so many places where we need that. So I'm so glad that you kind of came away with this idea of that this is can be quite a serious problem, but one that engineers can take on. So job well done. Thank you.
Thank you.
So round of applause for Madison and Rachel, please.
Yes.
Well done, well done, Preston.
Thank
All
you
right,
so
thanks.
much, Preston High School. Thank you, Mr. Dawes. So
Thank
great to
you.
see you as always.
Great.
Yes.
All right. Thank you, Joanna.
Do we have any other schools who want to tell us a little bit about their findings? I see Mr. Lee. Any questions? Any questions for our college mentors too? Anything about the college process or some more of their experience in class?
And let us know. I'll spotlight you with Montebello,
Yeah.
any other schools here. And I can let you guys know and spotlight them if I see any hands go up.
Yeah, I just wanted to share a couple of more things that if I can just share for a bit more while people are thinking about questions and things like that. I just wanted to discuss a couple of other findings that I had during this lab. Number one, I couldn't believe how different the feather. I've spoken a lot about this, but for me it was quite impactful. The effect of oil on everything it touched. When I tried to clean this lab up after the fact, I still had sort of this oily film everywhere. It really, for me, shined a light on how difficult it is to remove that from the environment. And in terms of oil spills, I kind of wanted to just talk a little bit about the cost of a remediation plan. And I know you may not have had a chance to add up all the totals of the equipment that you used. I know you have that in your workbook that you can work from, but I thought you might be interested to know kind of what a job can cost in the real world. And so I found this really good resource that I wanted to spotlight. And this is, there is an environmental legislation that has been very good at helping to hold oil companies accountable and to make sure that we're doing everything we can to try to prevent oil spills. And this Oil Pollution Act, or OPA, went into effect in 1990. It went into effect after the horrible Exxon Valdez oil spill, which happened. So I know this is before you all were born, but it was a very big oil spill that caused a ton of pollution that we're talking about. And what happened was that over the last 30 years, a group of scientists have kept track of all the oil spills that have happened. And so you can see here a picture of the location, and you can see the coastlines, and you can see that this is happening in areas where not just where kind of oil refineries are, but also where there might be shipping lanes and things like that. And what this site allows you to do is you can kind of zoom in and check out some of these stories. So I tried to pick one where I thought you all are born around 2010. This was the date of the terrible Deepwater Horizon oil spill, which you can see there has cost billions of dollars and is still ongoing. This is one where a valve on an oil rig, there was an explosion, and then because of the damage, the people on the rig, some people were killed, and then they were unable to close a valve. And so lots of oil, millions of gallons of oil kept dumping into the Gulf region here. And so it's still ongoing, and you kind of hear a little bit of a story about it. But I thought you can also keep going, and you can see here's a much smaller spill near where I live in Washington, D.C. This happened in 2011, and here you had a pipe break in a power company discharging oil and affecting birds and the wildlife in the area. And here, this was hundreds of thousands of dollars rather than billions of dollars. Here's one in New Jersey. I think we have one New Jersey school with us today. So here, the big Hurricane Sandy that came through, caused some leakage of diesel fuel that was released into a creek. And here's one in Ohio. Anyway, I'm gonna share this with you all. Maybe I can put this in the chat just in case you want to look at it at another time. Let's see if I can add this to the chat just so you have it. Just because I thought it was, well, I might have to share it with you via email. Sorry about that. But I wanted to, I can't see the chat right now.
Oh,
But I wanted to highlight that, and I thought that it showed you the quantity of oil spills, but also the work that's being done.
that was awesome. And I'll help with getting that link available. And we do have a question.
Oh, great.
Amina and Morgan, I don't know if you can see, but there's a question in chat from Preston High School.
I saw that and I saw the nanoparticles, and it immediately reminded me of my science fair project that was like using nanoparticles to clean water. It's like ages ago. So if you ask me like detailed questions, I wouldn't be able to answer. But also, I think Joanna was actually mentioning how AI is another thing that is being considered as one of the technology like emerging and being used for this. And I kind of looked it up very briefly, just did a quick Google search, and it was that AI is being used to like optimize some of the automated systems, like the pipes, and stuff like that, that like help out to clean the water. So I would say that's what I know, but we can definitely also research a little bit more and then come back with like a more detailed answer.
Yeah, I also kind of wanted to touch on that. Personally, I haven't learned anything about those technologies being used, but I opened up like the course listing at Virginia Tech for classes next semester, and there's this one that's machine learning applications in civil engineering. So that also sort of goes hand in hand with the AI being used, and that can probably also be used in this nanotechnology and picking up and detecting those heavy magnetic nanoparticles as well.
Great. Thank you. Thank you for such a great question. Yeah, I mean, I think sometimes I know for the Deepwater Horizon spill, engineers had to figure out a pretty innovative way to try to close the valve that was leaking so much because it was very deep below the surface of the ocean, and required sort of a very intricate and complicated subsystem to try to get the submarine system to try to get the robotic submarine to try to get the valve closed. So if you ever want to look into that some more, there's a great 60 Minutes episode about the Deepwater Horizon accident and what the engineers did to try to close off that leak. I know we've had some other questions as well. Episcopal High School in Louisiana has asked quite a few questions about what kind of rules do we have against polluting and causing these oil spills and other discharges? And I think it's important to note first that, first and foremost, the EPA does a lot of monitoring, and we've got the Clean Water Act, we've got the Clean Air Act. These help prevent the discharge of toxic materials into our environment. In terms of our food supply, we have the FDA that monitors chemicals and pesticides in our food and tries to ensure, and also the Department of Agriculture. All of these work on monitoring to try to prevent to keep an eye on discharge to the environment and to hold industry accountable. So they're very important agencies. I would say in terms of another thing that question we had was how do other countries deal with discharge and things like that? And it's probably important to note that more developed countries, the US, Europe, the UK, European countries, they have more stringent requirements in place to prevent spills. Developing countries, which are growing so quickly and changing so quickly, they can have less stopgaps in place. And so I think in terms of thinking about how a European country versus a developing country is doing, certainly the more developed countries have more resources and more legislation in place. But that's not to say that the developing countries can't leap ahead because of all the lessons learned by the more developed countries. And Morgan and Romina, I think that kind of speaks to like the ethics of situations and things like that. I don't know if you have any thoughts on that topic about trying to prevent these things from an engineering standpoint from happening.
Yeah, I kind of wanted to touch on the first question about like the EPA. There's also the Department of Agriculture. Most states also have their own internal requirements as well. So I know for Virginia, there's Virginia Department of Environmental Quality, and that goes hand in hand with water, wastewater, and then there's also the Department of Health. So there's those kind of set the restrictions on making sure that people aren't going and polluting the waters. That also is part of making sure everybody does have access to that clean water. So making sure that all of the water goes and gets cleaned like before people are able to drink it again. So that's just Virginia. Maryland is pretty similar. I'm from Maryland, so and I've only really studied this in Virginia, but there's a lot of states have those internal regulations, and there's also regulations. Some projects are incentivized to go and get LEED silver, LEED gold, and you can kind of see that in those European countries as well, and developing countries. A lot of times, areas are incentivized to go ahead and get that LEED certification or the Envision certification, and that has a lot of it goes hand in hand with that leadership and the collaboration with the community, but also has a lot to do with the restriction of those polluted areas.
Those are such great points. I should have emphasized that also, in addition to the federal agencies, there's also state agencies that help protect their communities more locally. Romina, do you want to, students may not know a whole lot about LEED certified buildings and things. Would you know more about that? Or is that more Morgan, in terms of the requirements there?
I mean, definitely Morgan will be more like specialized on it, but I can talk about it as well. You basically, it's just certain like I guess rules or like practices that you have to follow when it comes to designing a building, or it's also like it lies on the architect side as well, of trying to meet certain standards so that you can achieve a more like cleaner building. So that's kind of how you achieve it, and it's graded by I think silver, gold, and platinum. That's LEED. But something that I did want to mention, since we're talking about like some of the like state and federal and like policy side of things, is that there was this class that Morgan and I were taking, smart sustainable infrastructure, and in that class we talked a lot about like the policy side of, not just in that class, in a lot of our classes, they talk about like the importance of engineers representing or like having a voice when it comes to like the policy side of things, and making sure that we are able to kind of communicate those needs towards like more sustainable practices. And so that's something that even the students can think about in the future, like in terms of like the careers that they want to have. They might not necessarily want to be engineers and take that route, but if they want to do something with policy or like those kind of things, maybe this is still something like interesting to them, so they could try to specialize in that. So that would be something to think about for sure.
I love that response. Yeah, certainly environmental and civil engineering has a lot of crossover into the policy realm. And so if you're kind of find yourself interested in the social sciences as well as the STEM areas, there's lots of crossover there that would allow you to use both of those interests. And maybe that's a good point, a good segue. I'm going to start sharing again with our last few minutes to see if there's any other questions from our groups who are our high schools who are joining us today. And in particular, maybe about your college experience and your journey to studying engineering in college. So I certainly will keep an eye in the chat for any questions, but you know, did it take a while for you to choose your major, both of you? Did you have some, I feel like maybe you go into college thinking you're going to do one thing, but then you take some other really interesting classes and that changes your mind. Did either of you have that experience?
Yeah, I can lead us off. So when I first entered college, um, I was kind of focused in on general engineering. That's how Virginia Tech works. So your first year, you're general engineering, and then the next year you declare. And I came in wanting to do environmental engineering, which is a subsect of civil engineering here at Tech, but that had a lot of chemistry, and I decided I did not enjoy chemistry. So I kind of switched over my focus into structures. And then I took a class called Intro to Land Development, and I was doing this one assignment, and I had so much fun doing it. I was like, wow, I'm having fun doing my homework. This is so weird. But that kind of made me think maybe I should be doing this with my career. And I ended up having an internship, and that solidified me into wanting to do land development. Um, and now I'm staying for my master's in sustainable land development, which goes hand in hand with the environmental engineering, with the water resources engineering. So my main focus is land development, but I also have been taking classes in water resources, kind of avoiding all that chemistry stuff still. But it is really important to understand the environmental engineers side of things, but I'm more on like the civil engineering side.
I love that answer. And I think something that you said really resonated with me as well. And that is that when you're working on an assignment, and this can happen in high school as well, that doesn't feel like work at all, where you're having so much fun, file that away and remember that, because that's helping you to understand what is it I really enjoy doing. how can I do more of that? What kind of career can I have that will allow me to do more of that? And we do have a question now, so I'm going to let maybe Romina speak to this one, which is, did you have an internship that you found particularly enriching?
Yeah, definitely. So as I mentioned, I have interned with a construction company for the past 3 years. I'll be interning with a structures company this summer. But honestly, I will say if you can do internships, do them. Doesn't matter, like as many as you can do in different fields, even, just so you gain an understanding of what you like and you don't like. Because for me, mine was in construction, and it wasn't that I didn't like construction, but I found out that, you know what, actually, I don't think that this is it for me for the rest of my life to be in construction. Whereas kind of like how Morgan touched on it, like when I was doing my structures homework, no matter how difficult they were, how challenging they were, at the end of the day, I really enjoyed solving those kind of problems. And so those kind of things, those two experiences for me made it so that I could kind of decide that I'm leaning more towards structures. But apart from that, even just doing an internship teaches you how to communicate, collaborate, like in professional settings, but also how things are done, seeing the management side of things, or how your knowledge that you're learning in school applies in real world. So definitely, I found my internship to be very enriching. And every experience that you end up doing, whether it's an internship, being part of an organization, or whatever, you get from it what you put into it. So that's something very important to remember, that if you want to like have that enriching experience, you have to put in an effort. You have to apply yourself, and make sure that you're learning every day from that. So that would be my answer. Hopefully that was a
Such
good.
great, such great advice from both of you today, I have to say. I think, you know, for high school students that are working on that group project, and maybe it's not their cup of tea, but if they can, if a student, a member of a team can add something that matters to them to the team project, in other words, doing the work, putting themselves in there, and you'll get so much more out of the project. And I think that's so true. I think I'll
Wait,
just
Joanna,
mention,
can I touch
yeah,
on
sorry,
something
go right ahead.
before we move away? So something else that I learned from my internships and group projects was how to email professionally and how to talk to people, like my boss, my manager, and just learning how to email and be comfortable talking on the phone with somebody I didn't know, emailing somebody I didn't know, Teams messaging somebody who's like the boss of me. That kind of allowed me to become like work on those soft skills, not just like my engineering skills. And that was really important. So I think working on that as soon as you can, if that is possible, that made me a lot more comfortable to work in those professional settings. So that's one of my recommendations.
Oh, such a good point. I'm so glad you added that. And that can start in high school as well. Writing a good email to your teacher can take a little bit of practice, but it's really, really a good skill to develop. And I highly encourage you to work on those soft skills because they're just as important as the technical skills. Um, Speaking of technical skills, you know, your way to engineering can take many different paths, and your career, as we've talked a lot about today, you can start studying one thing and pivot to another thing. There is no straight line path to what you do in your future. And so I'm putting this slide up here just so you can see the various pathways going from high school to to straight into industry, working as a manual operator, working, going to a community college and getting your associate's degree so you can do some of the technical work at a job, and then potentially if you get some experience after 2 years working at a technical position, you can get the company you work for to pay for your 4-year college degree. I know my husband is also an engineer, and that is how he made his way through college. And I did a program where I got to study 2 different majors, which is also possible if you start in community college and then go to a 4-year college. And then maybe I'll let Romina and Morgan just add on any notes about, I think you're both continuing on to graduate school, which I didn't do. Do you have any, what helped you to make that decision?
I can start us off. I actually, speaking of 2-year college, like community college and going into 4-year, I also took that route and I started off going to community college and then transferred to Virginia Tech. And I'm gonna continue here at Virginia Tech for my grad school. So that's kind of like an example. Like both Morgan and I are kind of in the same place, but our route to get to here looked very different. And even I remember like we were studying abroad, Morgan and I. And back then, I wasn't a Spanish major. I like neither of us were going into like grad school. Like none of that was still set in stone. And as we took more classes and became more involved with certain activities or organizations here, we realized, oh, actually, I like this too, or I might be interested in doing this. So it's as time goes by, your interests change, you become more aware of what you like and don't like. And so those become factors into your decision making. And so for me, again, going back to the homework assignments I did and I enjoyed, or the type of work I've done, and I was like, oh, you know, what I really love being able to design and actually understand like what goes into designing a building. And those kind of things helped me realize that I needed more knowledge within my field. And then I'll hand it off to Morgan to say her
Yeah.
reason.
So I went straight into the 4-year college here at Tech, but I didn't decide on graduate school until last semester actually. And I was just talking to one of my coworkers at my internship, and he said that, oh, I'm staying for my master's. Like it's only 1 year. You might as well do it. And I realized I was not ready to start working full time yet. And I really just wanted to learn more about how to do sustainable land development since you can't major in that in undergraduate. So I decided that I might as well just stay for 1 more year of school because who knows, if I had just gone straight into work, I probably would have ended up coming back anyway. So I might as well just stay for an additional year, learn a lot more while I still like am in my college mentality, college brain, like start graduate school as early as possible. But I'm really excited. I might come back and do my MBA at some point too, as you can see on this little pathway. But everybody's path is different. So it's been great to talk to you all today.
Yeah, gosh, Morgan and Romina, I just want to thank you so much for um, your stories and your advice that you shared today. Students who are listening right now and students who hear this later as a recording, please take some of this great advice to heart. You could be on the same path as Morgan and Romina in just a few years, and you heard how their paths were so different, but look at where they are and look at all the things that they've learned along the way. I feel so lucky I get to work with you and get to know you better. So thank you so much for your contributions today. Well, I know that it's time for us to hear from our keynote speaker, and I am really, really excited that we have Miss Ana Laura Arredondo joining us today. And is she here with us now, Jillian?
Yes.
Oh, I
There
see her.
she is.
Okay.
Good morning, everyone. How's it going today?
Good morning. Yeah, let me just tell everybody a little bit about about you and your background, and then I will turn it over to you. So, Miss Arredondo is originally from Mexico. She moved to the U.S. as a teacher and began her education taking ESL courses at the College of Marin in California. She went on to earn her chemical engineering degree from the University of Southern California. After graduation, Ana Laura worked in the oil field services company with Schlumberger in Texas and with a large gas distribution company called SoCalGas in Los Angeles. Now she works for the energy company Chevron, as I mentioned earlier in my introductory remarks, and she works in the Bay Area at a refinery in Richmond, California. Her expertise spans many areas: water treatment, hydrocarbon separations for gasoline, diesel, and jet fuel, as well as innovation in biodiesel and hydrogen power. Today, she is going to talk about her journey to engineering, as well as how the energy industry works in site remediation. Ms. Arredondo believes in the power of both kinetic and potential energy, which I know many of you high school students know about. But in her retelling of this type of energy, what she means to say is that some learn rapidly, while others persevere from disadvantaged positions. And that persistence enables everyone to achieve their goals. So please join me in welcoming Ms. Arredondo today, and I'm so excited to hear your remarks.
Hi, everyone. How's it going? Good today? I hope so. It's a beautiful day here in California. It was raining yesterday, so I'm excited to see some sun. And we still enjoy the fog regardless. So I'm going to go ahead and start my presentation, and then please let me know once you see my screen or give me a thumbs up. Just give me a second in here. All right, can you guys see my screen?
It's loading right now. Yep. We can see.
Okay, perfect. Okay. Awesome. Thanks, Johanna, for the introduction. So, yes, as you mentioned, my name is Ana Laura Ramirez Arredondo, and I'm actually a chemical engineer. And thanks for the introduction of the different, I guess, energy industries that I've actually worked with. And so, pretty much, I'm going to be talking about my bio, a little bit more about me, and then why chemical engineering and the advantages and disadvantages of being a chemical engineer. And also, as we were learning more about remediated sites, so I'm going to be talking about my experience and how is it that chemical engineers, contribute to remediate, some of the different locations, and also how we actually prevent. So preventing and mitigating, it's a lot of the things that we do. So we're going to be talking about that. And quickly, I'll show a sustainable engineering project that I worked during my college time. And then we'll move to Q&A. So my bio. For my bio, yes, as Joanna mentioned, I went to USC, chemical engineering. Some of the things that I'll always like to mention is the organizations that actually helped me during my time at USC, and then also how these organizations actually continue to be supporting my career. Even after you graduate, there's always support for engineers. So some of those are Society of Hispanic Professional Engineers, which I've been part of the board member at USC, and then continue to be supporting the local chapters here in the Bay Area. Society of Women Engineering as well. I also was part of the board member at USC, and then continue to be part of the board member here in the Bay Area as well, the Golden Gate chapter. National Academy of Engineering. This one is like truly, it's being an amazing, I guess, organization for me to be part of, because it started at USC and then winning some awards, and then continue to helping globally, especially women in engineering, and answering a lot of their questions. And we also have like essay contest. So we always want them to start thinking outside of the box. So we have essay contests about different technologies, different topics. So if you have time, check it out, National Academy of Engineering, Girl in Engineering. And then the American Institute of Chemical Engineers, because this one's a little bit more technical, and it's always learning about the new regulations and the standards that we have to follow as chemical engineers. Some of the hobbies, I love trail running, hiking, kayaking, and just as the and engineering students mentioned earlier, one of my things also is to do my master's in engineering, but more focus on renewable energies research. And with that, I'm going to be playing a little video, and then let me see if when you guys can see it. Should be popping up. Can you guys see it?
Yeah, we can, I'm starting to see it popping up, and if it has trouble playing, I've got it teed up and ready to go too, if you want me to share. I'm not hearing sound from it. You want, why don't I try to share it really fast, and then you can go back to sharing your screen? Okay,
Okay, let me see.
I'm gonna try to do
Can
it.
you guys
I'm gonna try to see if it works
can
from
you
mine.
see it?
I'm sharing now.
Okay,
and
sounds good. Okay, perfect. Yeah.
I got the little stupid annotate in the way. Let's see if I can get it to go. And folks
My
here.
name is Ana Laura Redondo. I'm a student here at USC and I'm studying chemical engineering. I'm originally from Mexico, from a little town called San Luis de la Paz. And I moved here when I was 15 years old. When I came here in the United States, the mentality was that I should be cleaning houses and I should be a nanny. And that's what, you know, a lot of us do. I didn't know what I wanted to do yet. I wanted to just work and help my mom economically back in Mexico. But then once I picked up the language, once I saw those opportunities that teachers actually believed in you and they told you have the go take any class you want and you can learn anything you want. So that's when I pretty much said, you know, I'm gonna do it and pursue my dream, what I wanted. At the beginning, for me, math back in Mexico, it was the only way that I could actually control my life. It was something that I could easily solve, you know. It was a way for me to forget the problems back at home. When I saw that I could be an engineer, I said I want to pick the challenge, the most hard, you know, engineering field. So chemical and energy is what I've chosen. Yeah. My whole idea is to actually bring, you know, a different perspective into the energy field. Something that's always in my mind is that energy cannot be created nor destroyed. So we have to transform it and something has to, we have to give up something, right? So transformation means that we're changing one thing to another. And that's my whole idea. How can we make that transformation better? When it's like it supports you and you can feel it even in the weather. It's like go and do great things and change what you don't like and be supportive to others. The American dream, it's like a new door. It's like the new beginning. It's like an opportunity, like someone opens a door and tells you, leave behind, you know, what your past or what you went through. Come, you know, there's so many people like you that been here that have shaped America, you know, you come from different places and you become to be this one essential, you know, and unique person. That's being American.
All right. Thanks, Joanna. Yeah, I guess there was some difficulty. Some difficulty. Yeah.
Such an inspiring story, Ana Laura.
Thanks. And it kind of also seemed like it was a little bit like lacking in terms of the time, but maybe we can share that link with the students as well so then they can watch it in their own time. Can you guys see my screen?
Yes.
Okay, great. I'm gonna just continue going back to where I was talking about myself. And then, so now moving in terms of my career map. But before I get to that, I wanna talk about this point. So it's like, I went to College of Marin And my background, it's a little bit different. Like I didn't get to actually do high school, like 4 years of high school. I did 1 year of high school in Mexico. I did middle school in Mexico, and then I came to the United States. And as Joanna mentioned, my career started with like learning English. So pretty much that was my main goal. It's like, hey, I want to learn, another language. And then from there, I ended up, at College of Marin, junior college or community college. And then from there, it was like started taking, some credit classes like writing, art. And at some point, they're like, Anna Laura, maybe you should just do exams. We want to know your levels of math and science. And so once that happened, they were like, oh, maybe you should, try to like do some engineering, classes because it seems like you like math. And I was like, that's great. So, the counselors at College of Marin really guided me to like, pursue my degree in engineering. So, and even to the point that I ended up, being part of the College of Marin student trustee. So bringing a lot of the issues, that the students had, and then trying to make a change. And that's really where I think my career map is started. And I like to point that out because even though I didn't have, the same route of going through high school, it's possible to still go to community college. It's possible to still, learn some or discover what you want to do in life, take some classes. You can also take, advanced AP classes in community college while you're at high school. You can, explore art, you can explore liberal arts, you can explore whatever you like. So it is okay to not be so perfect in high school and not have like the best grades. We don't want students to like stressed out about it, but we do want them to understand that there is many opportunities, and community colleges are really a great step to like make sure that you flourish, make sure that you continue with your education and discover really who you are. So that's what happened for me. So that's why I like to point it out there. And you can also give back to your community. So it's a great way to connect with your community. And then from there, I transferred to USC. I didn't know exactly what I wanted to do, what kind of engineer I wanted to do, but based on my grades and also based on where I wanted to make an impact, I selected the engineering that had the lowest percentage of women in the field and also of women of color. So that kind of narrowed down to where I wanted to go. So chemical engineering really is where I was accepted as college. Colorado School of Mines accepted me first, and then USC, and then USC was my second option. But then somehow USC is like, hey, we give you a full scholarship. We want you to come to LA. So pretty much that's what I narrowed down my career path. From there, I moved to do my first internship. I really wanted to work in the field. I wanted to know where energy really comes from. So I wanted to understand the raw materials and then, move later on. As you can see in my career, I moved through like 3 different processes and then to even getting to like the final product. So I did my internship, fell in love with Schlumberger, the community, the culture, the support, and then continue after graduated, went to Texas, was there as a hydraulic engineer, field engineer as well. And then after that, I moved to more like technology. So I ended up doing like digital solutions, Internet of Things engineers was really what I wanted to do. And once again, it's like even though I'm a chemical engineer, you can end up doing other things. But the important thing here is like this is also energy. So there is digital solutions within the energy. There will be digital solutions in your house, like how to when you can turn on your heater through your phone. So those are kind of like the more AI digital solutions and connections with like Internet of Things. And then after that, I wanted to come back to California. So I got an offer to come back and work for SoCalGas, which is a midstream. So all of this is upstream, what we call. So it's like the beginning of the process of energy. And then you go to midstream where you move some of these products into a different state, a different place. And then from there, it gets to be processed. And then from there, it gets to be distributed, to the clients. And then, so this was still midstream. And then lastly, now I'm in the last step of the downstream part of it where we get more products. So pretty much my point with this is like, it doesn't really matter the race that you're doing. It's just it matters that there is different ways to get there, and that's one of my things to mention to you guys. It's like the finish line is there. There will be different paths, and then you're gonna select the right one. So why chemical engineering? It's because chemical engineers really touch in a lot of things. We not only get to change the way we approaching climate. We get to prevent, one more time, things and the climate change. We also get to like incorporate and provide new energies. We also get to continue and improving the current way we provide energy. Sustainability, we always want to be sustainable in anything that we do. And then human and health, we always want to protect our earth. We want to protect ourselves. So this is a lot of where ethics really come into place, because we touch a lot of things. So, and then right here, so wanted to mention this pictures because this one's Chevron, this is Schlumberger, and then this is just a little bit more research that sometimes chemical engineers get to do. And I'm gonna play this little video. Hopefully, it'll. Let me know if you can see it.
Yes. It's loading, yeah.
I don't hear the audio again. I've got it teed up. Do you want me to try to play it for you?
Yes, thank you. I should have just mentioned that to you.
If you stop sharing, then I'll quickly share. Great. I hate that when the audio doesn't work. Okay, here we go.
Chemical engineers do. Life-saving medicines, accessible to everyone.
Develop and deliver new energy sources safely and responsibly.
Plastic waste from our oceans.
When it comes to getting things done, chemical engineers have a pretty full to-do list. We do the math, science, and engineering to make medicine accessible, water drinkable, air breathable, the deep thinking to make the environment sustainable, systems affordable, safety reliable. We make discoveries scalable and the inconceivable feasible. So what in the world do chemical engineers do? We take things that have never been done and get them done for good. DICHE, doing a world of good.
That was great. I just think there's you just heard such a broad scope of the different kinds of things that chemical engineers can do. So take it away.
Yes, yeah, you can make medicine. I'm sorry. Yeah, you can take medicine. You can make medicine, which is something that I didn't get to pursue, but I still do energy, and then energy, has a countercount with climate and sustainability. So, but there is many options that you can pursue as a chemical engineer. And then, can you guys see my screen? So now moving into the advantages and disadvantages is like any engineer, you're gonna gain analytical thinking. So it doesn't matter, what kind of engineer you decide to be, but just know that you start thinking in like a broader way. You start connecting a lot of things, how everything gets to be made, how problems actually we solve problems, but sometimes there is other problems. There's a lot of troubleshooting along the way. You get to learn those skills, and you do it by more like hands-on. You become very extremely adaptable, like thinking outside of the box, being in extreme positions, I guess. Sometimes like pressure, you have pressure to like solve xyz problems, but at the same time that is the opportunity to make a change. That is the opportunity for you to bring your input and think it in a better way, always, once again, ethically, and thinking about everyone. So that's where you get to make the change. It is pretty highly competitive. And I mean, not only in the chemical field, but in other fields, it's pretty competitive. But at the same time, is like you learn that there is always a continual learning. There's not only in your designs what you do, that you have to properly design it, then it gets to be operated, and then you have to maintain this process. So there's always this continuous learnings of like troubleshooting and improving. But at the same time, some of the disadvantages is like you get to like impact the environment. As I mentioned in my video, in the Guardian, energy cannot be created or destroyed. So if we're only transforming things, how do we transform it? Is the key component. Do we want to transform it in a way that it's more sustainable, in a way that affects less the earth, in a way that is better for humans, solving some of the health issues, things like that. This is where we also get to understand, because things are not just like black and white. There's a whole shades of gray, and there is where the complexity really exists. And so for us to understand that is important, and it's a disadvantage, unfortunately, the negative impacts that happens from creating one thing. And so that leads me to, when we don't create good designs, there's, issues that can happen. As you guys have been learning, there's, oil spills that can happen in the energy industry. There could be air quality that it's not, to the right levels for us to inhale. There could also be, issues to the water if we don't design properly, if we don't prevent. So it's important for us to really, really have, once again, that the ethic component, to follow our regulations, and also those regulations need to be strong enough, and they need to be, and the caring way. They need to change. Sometimes they need to evolve. So that's something that we follow, especially as a chemical engineer, really rigidly. Air quality, regulations, EPA, energy regulations, such as CO2 emissions, like how much can we actually emit per day, things like that. And then if we go beyond those, you get to be regulated in different ways. So for me, I spend a lot of my time in the prevention way. So it's talking about the upstream world. There was a question about, a hydraulic fracturing. Can hydraulic fracturing really affect, the water? Can that increase earthquakes? Like, how does that impact it? Because even though it's not a remediated, but hydraulic fracturing, earthquake, it's kind of like you're shaking. That also already has like a consequences with humans. That also has a consequences of how, like, the fluids in those rocks get to actually move, and then landing into waters like rivers and lakes. So it's important to understand that it's a complex kind of a way. So I got to do hydraulic fracturing, and my way to see it is like I had to make sure that my casing, everything that we were using in cementing, was protected. So it was kind of like the environmental side of it, ensuring that everything stays in the pipe, ensuring that we were doing research for new chemicals that were much more healthier for to going into the ground. ensuring that the water that it gets to be, kind of like coming back, we call it the flow back, that water gets to be treated, that we still need to, filter it, and if we want to utilize it, because water, it's also a resource that is, less source. We have sometimes a scarcity in water. So we want to utilize that and recycle it. We want to protect the earth. So I got to do a lot of the prevention part of it. I got to learn where the raw materials really come from, and then how from there, you turn all of this stuff into, let's say, the bottom of your shoes. Even your shoes have part of those products. So it's important to understand where everything comes from. Luckily now we're changing a lot of the plastic, to be more stainless steel. But even stainless steel has a consequence. It has a carbon footprint. It comes from somewhere. So prevention, I got to do that going back to where I was, hydraulic fracturing, and then I got to also do it as an integrity engineer in the midstream. So once everything is get out of the wells, then we transport it. Once again, it's also like through pipes. It could also be I guess an encapsulated kind of a pressure vessels. So sometimes we move those through, through driving. That has to be really protected. What if, something happens? But mainly I got to do it as an integrity engineer, the pipelines. What's the component of the material? Can that withstand, what we're pumping inside? What are the chemicals? Can that be thick enough? How often do we actually check for those thickness? How much does it get to be regulated? Can we report every time? We have to report every time we inspect these pipes, and then the status of it. Because some of this goes through high consequences areas, meaning that they're going through, like a high populated areas, going through let's say there is a community, so that we already consider a high consequence area. So we have to think about those. Some of those also get to go in the ocean. Can those pipes, sustain all of this pressure, all of these chemicals, and then ensuring that they don't leak? So this is a lot of the prevention. There's a lot of work that goes into it. Like, you have to do ultrasonic readings. You have to do some x-rays, kind of like they do the x-ray for your hand. We also have to do it for pipes. So it's like all these amazing technologies that get to be included into ensuring that we get to have energy. So now every time you turn your light on, every time you turn your car on, think about the process that has taken for us to have, this accessibility, for us to have the ability to drive and to move, the ability to even fly. So it's kind of like important for me to still work on the prevention side of it, ensuring that, we're up to our standards, and then finding all this, discrepancies, and always ethically, bringing and being, I guess, open-minded, and be very truthful at the same time of your findings. So that's where I am. I've done some mitigations, like in the water, especially, but I don't do it as often. We do it in the mitigation if something bad happens. So I don't really want to be in the mitigation side of it, because that means I probably didn't do my prevention work very well. But there is also times when you're so close, let's say, of a pipe that's pretty thin, and then what do we do now? It's like you're gonna leak, or let's say some of your furnaces, it's like the sound could be pretty loud, things like that, or your air quality. Unfortunately, some things happened, and your process is not perfect. So because it's not perfect, sometimes there is unexpected higher CO2 emissions. So now you have to worry about this. So I really don't want to be in the mitigation part of it. I want to still stay in the prevention part of it. But yes, that's what I wanted to mention from that side of it. But we touched a lot of things. And now, lastly, moving into this project. And the reason why I wanted to mention this is because I did this at USC, and I know you can do this in a lot of universities. And it's also something that if you're already in high school, you should start kind of looking. If you want to be an engineer, look at the National Academy of Engineering, and they have lots and lots of challenges. As I mentioned, there is the write your technology essays. We review them. There's a competition. So it's like kind of thinking outside of the box. But this one, back in 2017, USC was like, had a challenge of like, hey, we want to, engineers to think not only in the technical way, not only to theoretically, be involved on like math or like computer science or, of research, but we want them to also understand their impact. That every time they do this research, how much is that going to impact, Earth, people? So pretty much, if you had, and I call them the test parameters, because these are the 4 components that you had to like focus on: be sustainable, maintain, a health and security and joy of living. This was for a community, regardless of where it was. It's like we want to make sure that these testing parameters in a community are continuously to be improving. So pretty much the problem was just like, hey, can you, like, what are the engineers that already are doing hands-on project, but at the same time they understand the broader general of education. Like they understand that if they're doing a research, it's going to be a product that they're going to have to sell it. What are the economics? What are the policy science behind it? Like, are they following, mechanical regulations? Are they following chemical regulations? And then at the same time is like, can they be innovators? Can they think in the entrepreneurial kind of a way? Can they help solve, some of the most complex third world issues? And can they also be kind enough to, to share this knowledge, to provide this knowledge in kind of a free way, pretty much. And so that's what the abstract was about. And then luckily, the way I was able to win this award is I did my internship with Schlumberger, which was when I was mentioning to you guys that the pipe needs to be cemented around it, going under the ground. So one of this was for me to test one of the new cements and then ensuring that it was going to work for formations like in Bakersfield. So it's like if your formation is like pretty we called it brittle, so it's like so easy to like move, it's pretty loose, you're not going to be able to have maintain this pipe in the ground and then cement it because it's not going to hold. It's like let's think about your wall. If your wall has a foundation in the ground, if that foundation is it's in a pretty loose ground, then it's not going to hold. So my research was, what is the right polymer or additive that can hold at those loose pressures and like higher temperatures, can that it's still like solidify? So that was one of my things, and that's once again to helping maintain keeping everything in the pipe, ensuring that nothing goes out of the ground. So that was one of my research. At the same time, I was working in the very beginning of solar panels. So we have this competition with the solar car team that if we developed from the very beginning, designing, fabricating, and installing a car that would only run with solar batteries and having, I guess have the car go the longest distance, that was one of the challenges that we had. So we saw some of the first solar panels. I got to like install some of those, worked with some lithium batteries. So it was quite fascinating to learn about that. And this was back in 2015, 16. And then the other thing was, can we make a car? Another challenge, and this is a challenge for the American Institute of Chemical Engineers. Can we make a car that runs only with sustainable chemicals? Like nothing that gets to be, like lithium batteries. It's already a secondary process. Like it's already been through some transformation. But can we make a car that it can run, with just, I don't know, sometimes I use food. But in this case, mine was about just copper, aluminum, vinegar, and carbon, and then making sure that you make your own battery. So we made our own sustainable battery, and this car was pretty small. It was probably like 12-inch by like 8-inch kind of a car, and the chemical reaction is happening, and the car is kind of moving. So ensuring that this chemical reaction is timed at the same time with the distance. It was quite a fascinating research. So, and I was the co-lead for this one. USC got to be the first one to win the third place. So it had not we had not won anything before. So this was the first time we actually won the third place. That's still good. That's already a winning for us. We're already moving forward, changing things. Anyway, so that was really awesome. And the last thing is like I got to do some research, and I got to do research and pretty much compressed natural gas. So the current cars, what if you just instead of making more materials to actually build more cars to have more electrical cars or more hybrid cars? My research back then in 2017 was about use this current car and transform it so it can actually use compressed natural gas. So thinking outside of the box, using already your resources. Once again, you don't want to make more products. We want to transform what we already have, what's already existing on the earth. So that was one of my research of like converting this regular card, gasoline card, to a compressed natural gas card. So yeah, so pretty much that's how I was able to win this award. Once again, combining everything, thinking outside of the box, and not only technically, but also as caring about the environment and caring about your community. And with that, I'll let you guys, ask any questions.
Oh, Anna Laura, thank you so much. What an interesting career you've already had. We do have a couple, I feel like I have so many takeaways and so many questions. Um, but we do have a couple of questions in the chat, and some of them you've touched on. For example, in what ways did you leverage USC's research and career opportunities? Your last slide spoke to that so beautifully, but I found myself wondering, how did you find out about those opportunities? How did they come your way?
Yeah, no, great question. So USC had like different programs. It had like the Center of Engineering and Diversity. So they also had like their entrepreneurship, clubs. They had everything. So pretty much the engineering department, they're like, there is this wonderful challenge the National Academy of Engineering is doing. Like a lot of our students are already, doing this extracurricular activities. They're already, thinking outside of the box. They're committing. They're dedicated. Why don't we like make sure that they add more of it, like more of the economics or like third world problem solving, and see which of those actually get to uh, gain this awards. And then so they started it, and through this Center of Engineering Diversity, I learned more about it. And so because of that, they're like, hey, you're a great candidate. We should continue and then follow through this. You have until like the end of the year. So things like that. So it was really through like these programs, and they're doing their research and then bringing these opportunities to the students. So USC is pretty good at it.
Wonderful. Yeah. Well, I also think your story to get to college is so unique. And I know you got a scholarship to USC to attend there. Um, a question in the chat was, are there ways, how can you finance a college education, if you don't have the funds? And I know at Georgia Tech, and I don't know if USC had this, there's definitely the co-op program where you can get paid for a semester and work, and then you come back and you take classes, and there's a way to make your way through school that way. I think are there other methods that maybe you have become aware of, other than scholarships?
Yes. So I was actually working for USC. There's a transportation department, so then you get to drive the students around. So I was doing that in my evenings, and then helping. That was helping me with like food, things like that. So there's always like in-campus works that you can do. There's also research that you can potentially do if you want to do that you get paid for. And but yeah, the majority for me was scholarships and then was working at USC. And then, some of these universities, a lot of universities actually have understand that there is a lot of needs, and they actually sometimes provide you food. There is like the food banks that exist. There's many things. There's the support, and then scholarships. I think scholarships not don't feel like you only have to apply for one, or like just what the federal funding really is. No, it's like go and find more resources. That's kind of for me what it worked. I not only had USC to cover my tuition, but I also had like organizations from Marin County that were supporting me, that continue to support me. And then there's many in LA, there's many in the East Bay, in the East Coast as well that I remember. There's Society of Women Engineering, there's Hispanic Professional Engineering, there's all these organizations that I mentioned. They're still supporting, they have funding. So there's lots of research for sure that you
Yeah,
have to do, but
yeah.
there is also
Sounds like there's
great,
lots of
lots of
opportunity out
opportunities.
there.
Yeah.
Wonderful. Okay, and another question from Preston High School. Um, you've spoken a lot about how prevention is much, much better, and how important that is to you in thinking about any design that you work on. Do you find it, though, hard to navigate some of the legal aspects of your work? Do you get frustrated when you see perhaps corporations failing to account for the environmental, the preventative processes that you might find you're trying to employ as part of your design?
Yeah, I know that's a very, very, very important question. So I'm glad they asked that. I think there is a frustration of not seeing things moving forward faster sometimes, because like once again, like we have to like ensure, let's say if you have a leak, like anyone has to ensure it. If it, the mechanical association, ASME, they have their own regulations, and they have, depending on pressures and temperatures, they pretty much have like this code. This code, everything that you do to it, you have to report it to the state. So then for me to, alter it or something, it has to be reported to the state. Sometimes that takes some time. Sometimes you're like, oh man, I'm already in like, this really tight timing, ensuring that no leaks happen, that nothing gets to be, yeah, pretty much that nothing bad happens. So it can be frustrating when you're like trying to already prevent or mitigate something that can happen, and then it still has to be approved. But then at the same time is like, I want to make sure that we do it right, and this is where we get to actually collaborate. And I think this is where it kind of needs to be happening, that it's not about them winning and it's not about me winning. It's about thinking about people, it's about thinking about the consequences. And then if the state or regulations get to actually review the design and accept it, then it's already a winning. It's already, there's a second pair of eyes. So I think it's a sharing of knowledge. It's a sharing of responsibility, and it's not about being frustrated, but it is about doing the right thing. And there needs to be more of a collaboration between companies and between the state, the federal, and not thinking about profit, but thinking more about doing the right thing. You cannot live without energy, but can we improve it, and can we actually make it better for them? So I think it's a collaboration that needs to happen. Less individualism, more of a collaboration.
So important, and a theme of what we talked about today. And I do think it's so important. And I I just want to share that I think your words and your story are so inspiring, and I know will mean so much to the students who are here today and who are listening. Um, I think your talk about the fact that we all have different paths, but we all get to the same finish line. To me, that is something that echoes with me, and I think with many of the students who are participating. Everyone is different, but we can all get to the finish line. So thank you so much. I also want to send a shout out to our engineering college mentors, Romina and Morgan. So thankful for their good advice today. I want to send a shout out to Mr. Jerry Dawes and Preston High School and thank them for their great involvement today. Here's Marina Regina High School, also in New York. They were working hard today. Samuel Clemens High School, you had some great questions that you submitted earlier, and I can see you working there. And here's Morgan and Romina. And then here, thank you so much again for your remarks today and for the advice that you shared. I think that transformation of energy to make something better is something we can all take with us today. So thank you, Ana Laura.
My pleasure. Thank you. Thanks, everyone.
Thanks, guys. And Ana Laura, just wanted, if you're here, there's a comment from Mr. Lee in Montebello High School who says, we have a lot of our students that want to go to USC and we're fascinated by your presence. And I think that sums it up. We all were. Thank you.
Oh, thank you. Thank you. And I appreciate it. But any university, you know, it's good to a community college, not just USC, but finding the right resources is important for them. So yeah.
Yes. Thank you, teachers and students. We had an amazing time with you guys today. Hope to see you soon. The next one is a big event for electric vehicles on Earth Day. So April 23rd, hope to see you. Submit those exit tickets and we'll see you soon. Thanks again. Bye, guys.